Today I'm showing how to issue license files to customers to protect your experts and indicators from unlicensed distribution. So when the customer has your indicator or expert, they can't simply give it to someone else without giving them the license file. And I'll show you how you can make sure that that license file simply won't work for someone else. This follows an earlier video where I showed techniques that were mainly intended for cases where you've done commission type work. So you've been requested to write an expert or indicator. You want to give the code to the customer so they can test it, but you want to make sure that they will then pay you and that it will stop working if they don't pay. So those earlier techniques were about embedding licensing and expiry information in the code. With these license files, this is a technique where you can issue the code once, or your compiled code once, and then reissue license files to one or many customers and include expiry dates and times in those license files without having to recompile your code. Now, before I go too much further, one of the comments that I got several times from the earlier video is that this technique does not protect your code against decompiling. I have a video in the works addressing that, which may or may not be released one day. So yes, I acknowledge that nothing I'm going to show you today will protect you from having your code decompiled or from being hit by a dinosaur-killing asteroid. So there's no point in leaving comments about that. There are only so many keystrokes in a lifetime. I also want to mention there's a similar video about including a password in your code from a channel called JimDandy. I'll have a link in the description for that. You should check that video as well, and he has a lot of other good code on Metatrader 4, so you should check his channel as well. So now let's go into the code and I'll show you how you can write a class that you can use to manage those protected license files. Now I'll explain some of the constraints that I'm working with first, because in this tutorial I'm going to show you how you can issue a license file. So that's an actual file that needs to be on the customer's computer. The first constraint that I'm working with is that I'm not using any DLLs or third-party libraries. I try to avoid those in these tutorials, so this is all Metatrader code. I'm using Metatrader 4 here for the demonstration, but everything will work the same for Metatrader 5. There's no difference. The second constraint is that Metatrader prevents writing or reading from files outside a given location. So if I go to, on the menu, File, Open Data Folder, then here this is Metatrader 4, so I have an MQL4 file. If this is Metatrader 5 you're using, then there'll be an MQL5. Inside that, there is this Files folder. And by default, when you use the file functions in Metatrader, they will only access files inside this Files folder. So here I've created Orchard, License, and here's my Product 1 license file. So because I'm working with the constraints of no DLLs, I can't go outside this file structure to store and read files. And so that's the primary constraint that I'm working with. The second constraint that will become more obvious in a minute is that I have no access to information about the computer where this is running. I don't have an easy way to get something like the computer's GUID or the IP address or processor number, anything like that. So there's very little information that I have to work with in terms of restricting the use of the license to only this computer or this user. And those things will become obvious in a moment when I show you what I'm putting into my license file. The constraints also mean that the client or your customer needs to install this file in this folder, whichever folder you choose. In my case, it's Files, Orchard, License. I'm not demonstrating how to retrieve this from an authentication server. An authentication server would be such that your expert or indicator can send information to the server and retrieve a valid license based on that. The writing of that authentication server is well outside the scope of anything I'm going to be talking about here. But I do have a future video coming where I'll be showing how you can download news feeds, and the techniques in that can be adapted to download this file from some central server. So you could possibly generate these files and store them in something like Google Drive or Dropbox, and then issue the link to those files to your customer, who can then insert that into a field in your expert or indicator, and then your code can retrieve those files from the shared folder and store them here. So a little bit of an explanation there, but that's a slightly better approach than I'm going to be showing today, but it makes this video too complex to include all of that. And as I said, there will be a coming video very soon that shows how you can download news feeds, and it's very easy to adapt that to download and then store these files in any location that you choose, as long as it's underneath this files folder. So while I'm here, I'll actually look at this product.lic file. I've named these as .lic. You can change the name if you like, and you'll see in the code how we do that. And I've already associated them with Notepad for opening. So if I open that, you can put anything you like into this file. I've chosen 3 pieces of information. There's an account number, which this will change from account 1 when I actually run, and it will be replaced with the actual account number that I'm using. There's an expiry date, and I've added this grace period. So you can see I'm expiring on the 14th of October 2021, and I've got a grace period until the 17th of October 21. So the reason for these 3. Account number is something that I know is reasonably unique. It's entirely possible that 2 different brokers have issued the same account number, but the chance that someone will have made a copy of your code and this license file to use with a different broker and just happens to have the same account number are so small that I'm just not going to worry about it. So by embedding the account number in the license file, I know that the customer who has this can't simply take this code and run it on another computer with a different account number. They can run it on any number of computers with the same account, but they can't use it on a different account. So I'm effectively locking this license into this account number. The expiry date, that matters if you're going to have time expired licenses. So if you want to have a subscription type license where the customer renews every year, then you can issue this with an expiry date here, and after that expiry date, it's actually your choice what happens. The licensing system I'm going to show will simply return all of this information, and you can do what you like with it. And that's why I say you can put anything you want into this file. And I've also added this grace period because sometimes people get right up to the expiry date and haven't renewed. So at this point, I could, in my expert advisor, begin popping up messages every 10 minutes telling them their license has expired, they need to renew it, or it's going to stop working. That's entirely a choice thing. That's got nothing to do with the licensing itself. That's just how you want to run the license. This top line, though, is the important one. And this is the key to the license file. It verifies, by using hashing, that all of the details in this file haven't changed. And that's why I'm quite comfortable about having the account number and the expiry date in an open text format, because it is almost impossible for the customer to change anything in here and still have this file be valid. Because any change to any of this data will mean a new hash is required, and there's a key piece of information, which is a license key embedded in the software, that's needed to come up with this hash value. They can't simply create that from the data here without knowing the key that you've embedded in your application. So those are my 3 pieces of information. As I said, there are constraints on the information I can get about the computer, so I can't lock this to a single computer because I don't know the computer ID, and there's nothing in the Metatrader 4 software that will give that to me without using external DLLs, and I'm trying to avoid that. But I do have the account number. You may think that you can lock this down further by also including the broker name or the broker server name, because you can retrieve those. But I would warn against that, because that information can be changed by the broker at any time. And so if you've embedded that in your license and the broker decides to change the name that they're sending out to the client or change the name of their server, then you'll find that the licensing will stop working. So I suggest just use the account number. The chance that 2 people are going to have the same account number with different brokers and have taken a copy of your software are so small, as I said, I'm not worried about that. So that's the license file. I'll also mention the name of this file, product1.lic. Product1 is actually the name of the product or the example expert advisor that I'm going to be using. So the key pieces of information that are embedded in your software are the product name, being product1 in my case, and the secret key that is used in creating this hash value. Now I'm in the Metatrader 4 editor, and in the earlier video I created this file license check, and the file is here. You don't need to see the earlier video if you don't want to. Everything I'm doing today is fresh from the beginning, but here is the earlier file, and what I'm doing has some similarities but quite different in many other ways. So I've already created the license file check.mqh file. That's this one here. and I've just put the standard statements at the beginning. So first I'll just declare the class. Now, as I said when I was showing the file, there's a product name that's going to form part of the file name. There's a product key that is essential to creating the unique hash value. And then there's the data, which is everything else that you're going to be putting into the file. And that data is entirely up to you. I put 3 pieces of data on different lines. If you wanted to perhaps issue this for multiple accounts, you could make the account line comma separated. So you can do whatever you like inside that file. And the interpretation of the data is entirely up to you later. And then I have a function for license path that will create that path name to the license file. As you saw, mine was inside the files folder, and then it was orchard license product name.lic. If you want to change that, you can change it when we get to this license path function. And I chose to create a function for that because I actually build the license path in 2 different places. And so if you ever want to change it, it's convenient to have all of the concatenation done in one place so you don't miss a change somewhere. So now the constructor and destructor, there's nothing in the destructor. I've just put the opening and closing braces there. For the license file though, you do need to supply the product name, this which will form part of the file name, and then the product key that will go into all of the hashing. And then I have a number of other functions. The check function is going to be used simply to determine whether there is a valid license file and then return or make available the value from that license file. The Keygen is a function that I've made it public here because it's also used by the license file generator, which we'll get to soon. That's a script that will create those files so you can distribute them to the client. And then FileGen uses the Keygen. So Keygen creates that hashing value and FileGen generates the entire file. And then getData will retrieve the data that has been read from the license file. So check will determine if it's a valid file, and the getData is simply returning this mdata value. So that's the value that has been retrieved from the file already by doing the check on the file. And the constructor itself is very simple, because at this point all I'm doing is storing the product name and product key that have been passed in. So in your Expert Advisor, you will create a license file object and you'll initialize that with the product name and product key, and after that you can continue to call. Why you might want to call it multiple times, possibly if you have a very short expiry on that, you want to know when it expires. Some people will have an Expert Advisor that runs for months without being restarted. So you might want to check this every day to see if you've passed that expiry date. So you'll create this object once, the C license file, and then you'll simply call the check on a regular basis to determine if this license has expired. So next is the license path function. It's very simple. I'm doing a very simple concatenation, and as I said, the only reason for having this function is that I only need to change this in one place if I decide to change the place where I'm storing the licenses. Now, obviously for my purposes, I'm storing them under Orchard license. If you're issuing your own files, then choose a different path. But just remember, this path is going to be used inside the class file, so it's not something you can readily change in each Expert Advisor, at least not the way I've written this class. And it's simply Orchard license using double backslash, because a single backslash is a special character in a string. So I'm using a double backslash to create one backslash, the product name, and then I'm adding .lic. And now the check function, because this is where a lot of the work happens. As I said, I'm getting the license path by calling the license path function, and then I need to read the license file from the computer. And the function's already available in Metatrader 4 for this. There's the file open function, where I pass in a path name to a file, and this path name, you'll remember, is underneath Orchard license. That is already inside the files folder that I mentioned in the constraints. So the license path, I'm opening file underscore read, so I want to read the file, or file underscore bin. So I'm opening a binary type file for reading. It's not strictly a binary file, you can read it, you've seen that we opened that, but file bin just gives me access to certain read functions. And then I'm checking if the handle is invalid. So that could happen because this file does not exist, or because I don't have permissions, which shouldn't happen, but for any number of reasons, you might get an invalid file. If that happens, I'm simply going to print a message, could not open the license file, and this %s will fill license path into that placeholder, and then return false. So your expert advisor can simply call check. If it couldn't read the license file at all, which may mean that the license file doesn't exist, then it will return false, and you can take whatever action you feel you need to in your expert. So after that, I need to read the value from the file. So mdata, remember, is the global variable that holds the data from the file. I'm just initializing that to an empty string. Get the length of the file using the file size function. I'm casting that to an integer because this actually returns a ulong, but I'm using that value, len or length, in the file read string, which takes an integer. So I'm just casting this file size result back to an integer. And then the file read string function, using the handle and length, will read this length many characters from this file. And given that I've just called file size, that should be all of the characters from the file. So I'm capturing the size of the file in the len variable, and then I'm reading all of the contents of the file into data, and then I just close the file. So this is assuming that these are not enormously large files. As a license file, they should be roughly the same size as the file that I showed you, and this won't be a problem. So I'm not trying to read anything of gigabytes of size. And the next thing I want to do is strip out that encrypted string at the beginning of the file. Now, in the file format that I'm going to be using in this class, that first field is delimited by a new line character. So \n is the new line character. So I'm searching for the first new line character in the file. That gives me a position of that new line character. If I don't find a new line character at all in the file, so if position is less than or equal to 0, then it's an invalid file. So my file must always contain that encrypted string at the beginning up to a new line character. And if the license file is not valid, then I return false, just as I did here, and you can deal with that error as you see fit inside your expert or indicator. And so now that I know where that first new line character is in the file, and I don't care if there are any other new line characters in the file, so you could put all of your data on a single line if you like. I'm only assuming that the first line is that encrypted hash value, or as I'm going to be calling it, the signature. So now that I have the position of the new line character, I can extract that. So I'm declaring a string variable called signature using the string substr, and that will parse through data beginning at position number 0 for pos characters. So this will give me everything up to but not including that new line character. And then mdata is just everything else in the file after that new line character. So again, with the string substr and still using the data, which is the original data that I read from the file, so that's everything in the file, beginning at pos +1, so that's the first character after the new line, and I'm not using the third argument here, which will default to everything else in the string. So after these two statements, signature contains that first line of the file, and mdata contains everything else. So now that I have that, and remembering that I'm saying that your expert or indicator is responsible for checking the values in the file to make sure that it hasn't expired and it's the correct account, all I need to do now is verify that the signature matches the data in the file. And so to do that, I'm calling the Keygen function, which we haven't written yet, but will soon, and passing in all of the data from the file, this mdata, and that gives me the key. And the key must be the same as the signature. So if the key is not the same as the signature, or if key is not equal to signature, then it's an invalid license, and again, I return false. So all this class is going to do is verify that the license file is valid inside itself. It is then up to you to determine whether it is for the correct account number, for the correct expiry dates, or anything else that you've chosen to put inside that file. And assuming we get this far, I can just return true. So the contents of the file is stored in this mdata, which we can get back using this getData function, because that simply returns mdata. And as normal practice, I'm not simply exposing mdata as a public variable. So I'm only returning it using this function, and that way the external expert or indicator can't accidentally change this data. The essential thing here now is this Keygen function. And Keygen takes a single argument, which is just a string of data. So everything you want to store in your license file, you will pass into this when you're generating the file, and we'll see that in a script that generates the files. And when it's doing the verification here, everything apart from the signature is passed into Keygen to get the verification. And so to make sure that that string can't be, or the signature string can't be just generated randomly by a customer, you need that secret product key. So this is only known inside your application. And all I'm doing here is concatenating data plus product key to create a string, which I'm simply putting into this key string. I'm declaring an array then of type uchar, calling it keychar. And then I'm converting that key string into a uchar array with the string to char array function. The arguments to that are the string, the array, the beginning character, and how many characters I want to convert. Now you can leave this last argument blank or not fill in the last argument, and it will take everything, but it will also take an extra character from keystring. Metatrader 4 strings are null terminated. So keystring has data plus mProduct key plus a null character. If you simply leave this out of the function, the null character is included in the characters that are moved into keychar, and so then your generated hash value includes that null character. So I just find it's better to do this, because if you're actually creating the encoding using some other application, so maybe you've got a website that does it, or you've got a third-party application that you're going to use to generate these hash values, they will want to have the same string being passed in, because even that extra null character at the end will completely change the hash value. And so by using stringlen, this will include everything in the key string up to but not including that null character terminator. And now to convert this keychar array into an encrypted string, I can use the Crypt Functions. So first I need to declare another uchar array, which is my crypt char, and then I call the inbuilt crypt encode function, and then that needs a method, and the method is crypt underscore hash underscore SHA-256. So I'm using the SHA-256 hashing algorithm. It then takes two character arrays. Now hashing only really requires one character array, but this same crypt encode function also does encryption and decryption. And in that case, you would be passing in a character array and a key array. There is no key array required for hashing, but the function requires an argument here. So I'm just passing the same array twice. So keychar twice in there. And that is my keychar made from that key string. So this is the value to be hashed. And the result of that comes back in this last argument, cryptchar. And then I need to take one more step, because the characters that come back in this crypt char will be any ASCII character, and I need to make sure that they are printable characters so that I can actually store them in this licensed text file. So to do that, I'm using encode again and declaring another uchar array. I'm calling it result char. Again calling crypt encode, and this time I'm calling crypt underscore base 64, which converts all of those characters to base 64 characters. Same thing here, I'm passing two arguments, but they are the same thing. So the crypt char, the result from this encoding into SHA-256. So I'm passing the crypt char array in, and the result comes back in result char. So that will give me a base 64 encoded value of this SHA-256 hash. And then to return that, all I have to do is convert this array back into a string. And there is already a char array to string function, and I pass that result char array, and that gives me a string value back, and I just return that. So this Keygen function will return a base 64 encoded hash value of the data that's passed in after it's concatenated with this product key. So keeping that product key secret is essential to maintaining the integrity of your license file. And so that's as much as is needed to check the license file, but I also want to use this class to generate new license files, and I'll be calling it from a script, but I want to reuse these functions. So I also have the function for a file gen, which will not only generate this key, but will also generate a complete file with the data included. And that makes sure that the format matches this format where I have the single new line character at the end of the hashed keygen. So this file gen function takes the same argument, string data. It returns a boolean which will indicate whether we've been successful or not, and it will actually write the file out to the correct path. So this is the second place where I have this license path, and that's why I used a function, because if I make a change to the way I'm generating the license path, it will automatically flow through to both the file gen and the check functions. Very similar then, I'm declaring an integer handle using file open, license path, but in this case file underscore write, but it's still or file underscore bin. The vertical line is the or. So file write, file bin, and then the same check on invalid handle. In this case, could not create the license file. The same placeholder here, license path, and returns false. And the rest of this function is reasonably simple. So I'm declaring a string signature and calling the keygen function with the data that's passed in. So in the case of my example file, that data would have been account number, expiry date, and grace period date. And then the contents is signature concatenated with a single new line character concatenated with data. And then I simply write that using file write string, using the file handle and the complete contents of the file, file flush to make sure that that data is actually written out to the file and doesn't retain in memory, and then file close the file, and then I simply return true. So this will create that entire file for me, and that is the complete license file check class. I'll just compile to make sure I do a syntax check on that, and that compiled. So this contains the essential functions that I can use. Let me scroll back here to the beginning. Keygen, which I may or may not want to use from outside, from my expert or indicator. In most cases, possibly not, but I've included it there as public. Check, which I obviously want to use to load the file and verify that it's a valid file. And file gen, which I want to use from the script where I'm generating these files. And then of course get data, because my expert or indicator will be reading the values that I've stored in that file to determine whether it should run or not. So next I'm going to move on to the script that I'll use to generate those license files. And I've already written it here, so we'll just work our way through this. And I actually have two scripts. There's the license file generator, which will create the file, and the license file test, which I can use just to test them to make sure that they haven't been changed. Nothing here is important. Standard property statements, property strict. This property, script underscore show inputs, is needed if you want your script to pop up an input screen before it runs. And I do have inputs here, so I need that to happen. I've included my orchard license check license file check.mqh file here. And then the three inputs, the product name. Now, this is the script where I'm generating the file. So I'm entering the product name here, and I'm entering the product key and the account number. In your expert or indicator, you'll have the product name and the product key embedded in the code somewhere, and you will read the account from the account functions. Now, this works where I have a file of the structure that I'm using. If you need to change the structure of that file, you can change the inputs. You might have multiple accounts that you're issuing to the customer. You might have multiple expiry dates, all kinds of things. This is my base example for the file structure that I have. So I'm declaring a type C license file pointer to a license file object. In the onStart, I'm instantiating that license file object using new C license file, and passing in the product name and the product key. And then I'm calling an internal function here that I've called make and test. And then I just delete license file to clean up this object when I'm finished. So the make and test function, this will both create the file and then test that it's been created correctly. And as I said here, I'm just making up some data. You can put anything in this file that you like. So my example, I'm using the account number, the expiry time, and the grace expiry time. So string data equals the account number, and I'm just using a single new line character, so I'm not using carriage return line feed. It really doesn't matter what you put in here as long as you're consistent in the way you store it and the way you expect to get it back. And then I'm using time to string with time current plus 86,400 by 30, which is 30 days. So I'm setting the expiry time 30 days from the current time. Another new line character, \n, and then my grace period time, time to string, time current, in this case 86,400 by 33, so I'm giving 3 extra days of grace. So that's the entire data string in my license file. As I say here, this is not necessary to do. I'm just running this for the demonstration. So I'm calling that Keygen function into a string signature. So I'm calling the license file object.keygen with my data, just so that I can print the signature of this file is for debugging purposes, really. And now I'm going to create the file using licensefile.filegen, passing the same data for the file, and I have a not here. So if that returns false, I'll simply print failed to create the license file and return, and there's nothing more I can do at that point. Assuming that was successful, I'm printing another debug message, created the license file, and then I go into testing that license file. And to do that, I'm using the same license file, but now I'm calling the .check function, and this is the same function you would be calling from your experts or indicators. If that fails, so if not license file.check, then it means the license has been created incorrectly. So this should never happen, given that I'm creating it and immediately reading it back. But if something goes wrong, I'll print an error message and return. Assuming I get this far, I have a valid license. So I'm again just printing a debug statement, valid license, declaring a string array called parts. I'm retrieving the license data using that getData function from the license file object. And then I'm using string split to divide that license data using the new line character. And these, note, are single quotes. The string split takes a character value here, not a string value. So using single quotes around \n gives me a single character value of new line. And retrieving all of that data into parts, which is this array. And then I'm just printing the values. My account number equals expires at, grace period expires at, and parts 0, 1, and 2. They come from the data values passed in. So I can run that now, and we will see the results of that in the Metatrader 4 terminal. If I just click Start Resume here, there's the input screen. I'll call that product X. This is the key that I would have. Also, I call that key X. Doesn't really matter what they are. But remember, these values have to exactly match the values that you embed in your expert or indicator. And for account number, I'll call this account 2 so the file changes. And then say OK. So it's come back here. Let's just flip back to Metatrader 4. And what we can see here, script loaded, gives me the list of the inputs. So product X, key X, account 2, initialized. Here's the signature that I've printed, BUFY, A1VM equals. So I've created the license file and then gone into testing. And the class has told me that the file is valid. So the signature that I've embedded in the file has been stored correctly and matches, and then these are the values that I've retrieved back. So seems simple enough. Let's just have a look at the file. MQL4 files, orchard, license. So here's the product one that I had earlier, and now the new productx.lic. If I open that, I can see it's account 2, and here are my new expiry times. And there is the signature, which matches the signature that we printed out in the debugger. If I change anything in here, and just save that, and now I can go back to the editor to my license test. So this is my license test script. The same script show input, same declaration of license file, same new C license file, and then I'm just calling a test function. The test function again calls license file.check, and because I've changed that one character, I should get a problem with the license. And if not, it will print the valid license values. So let me run this. First I'll clear these values, and now I'll just run this. Product X key X account 2, okay. And what we can see here, it says license is invalid. So that's come from the class file, and then oops, problem with the license, that is coming from my script. So the license is invalid because I've changed that one character, and so that hashed value on line 1 no longer matches. If I go back and just change that back again to account 2, and then I can rerun this. Now we can see the second time I've run this, initialized valid license, and it prints the values from the license. So it is not possible to change any value in there. You can't change the account number, the expiry dates, anything without invalidating that license, unless you somehow know the key that's going to be used to create that hashed value on the first line. Now to wrap up the code here, I have an example expert advisor. This doesn't actually do any trading, but it will show how to test the license. I've called this imaginatively license file check.mq4. Don't worry about this being an MQ4, the code is the same for Metatrader 5. Apart from these standard property statements here, I have two define statements. I have the product name and the product key. So the product name is important for the naming of the file that we've seen. You don't really need to keep that secret because it's obviously there in the product file name. And the other is the product key, and this is the thing that you need to keep secret. I've used a very simple here, key 1. You can make that anything you like, any jumble of characters. But this will need to remain the same in all future versions of your expert advisor or indicator, unless you want to reissue those license files at the same time that this changes. So perhaps you could include a version in your license file, and customers need to stay up to date with the version, something like that. The include statement here is the same as was in the script, license file check. I'm declaring the same variable, pointer to license file. I've declared a date time, which is my license check time, which says the last time I checked the license was time 0, which is 1970. So that's really just an initialization. And license valid at the moment is true. So these are global variables. Creating the license file object with the new C license file, and I'm passing these two define statements, the product name and product key. Remember when you make these define statements, put the quotation marks around the strings. And then return init succeeded, because there's nothing else here in this particular expert advisor. There's nothing on D in it. I probably should delete license file. That's a little bit sloppy of me, so let me just to clean up. But this is just an example. Now in onTick, I'm saying if time current is greater than or equal to license check time. I don't want to check the license every tick, so I'm just saying if it's greater than this check time, which remember we initialized to 0. So the first time onTick is called, I'm going to check the license, and then I'll check it periodically after that. So if the current time is greater than the license check time, then if not, license file.check, and we saw that in the script where we tested the license. So that is going to return false if the file has been tampered with. and then I can simply print invalid license. The license is not valid, so license valid equals false, and then I set the recheck time to 600 seconds, 10 minutes. So that way, if the file has been damaged or destroyed in some way, you can print messages like this invalid license, but it gives the customer an opportunity to simply replace the file, and it will be checked again in 10 minutes time. Now you can change that if you like, but I'm setting a reasonably short recheck time on this because if the customer has started this up without installing the license file correctly, it's a chance to fix it and not have to wait too long before your expert advisor or indicator starts running again. You may even want to make this slightly smaller. And then just returns. So nothing will happen in the onTick if the license is invalid. Assuming that was valid, then license data is my license file.getData. So that gets me all of the payload out of that license file. And you can test anything you like. And here's an example where I might say if checks failed. So assuming I've got a function where I want to test the values in this license data file, if the checks have failed, then I would set license valid to false. I would set my license check time again to 600, so I'm using 10 minutes, and return. So this is all the same as if the license file.check says the file itself is invalid. I would also run some checks, and if those checks fail, I would do the same things. Say that the license is not valid and test again in 10 minutes time. Assuming all of that passes, then the license valid is true. So I have a valid license file and I've tested the contents here. And the reason I didn't write code for this, because I don't know what the contents are that you're going to include. And in the case where the license valid is true, then I don't need to check in 10 minutes. I'm setting it to an hour. You could set it to a day, a week, a month, anything you like. So my next check is going to be 1 hour later if the license is valid. And that's all that is in my example expert advisor. I don't need to run this. There's nothing really that it can do. I'm just showing you how you might use it. And then of course in here you put all of your trading logic for the expert advisor. So that is the standard license file class. It's a class that lets you embed license files with any information you feel is relevant and to be able to verify that those files haven't been tampered with. As I said, there's a coming video on how to download news feeds into your experts or indicators, and the techniques in that are very similar to a technique you might want to use to download these license files. So while today I simply said the customer would need to install that license file on their computer, if you want to embed the techniques from the news feed, you can actually download those files from your own server or from a common file server. And then all you would need to do is make sure that the license files on your server remain up to date. If you found this video useful, then please click the like button. And if you want to see more of our videos, click subscribe and then click the bell icon to be notified when we release new videos. Thank you for watching.